Hi, I'm Dan. How's it going? Feel free to trust me and scan this QR code. Nothing bad's going to happen to you. Yeah. Damn it, I need to do that at one point. Yeah, this is just my LinkedIn, so if you wanted to connect with me, that's great. Most of you, I suspect, probably are connected to me already. Who's here for the first time this year? Oh, okay, decent amount of people. Okay, right, if you've not heard me speak before, this is an informal, I like the fact that we're in like a smaller kind of space this time, right? So please just heckle, like shout out questions, do not like wait for me to ask you like, hey, any questions, right? Please, like as I'm speaking, because I'm aware that some of you will know some of this, some of you will, like this will be the first time you've heard any of this stuff. So please, like it's a learning thing for all of us. Yeah, okay. So I've got 40 minutes to talk about how to design your Wi-Fi in 10 minutes, right? So let's figure out how we're going to do that. Okay, I've got a little clicker here as well. Nice. Doesn't work, brilliant. Let's try again, there we go. Cool, okay. Right, so Wi-Fi design, right? So I think one of the first things is that, I always talk about Wi-Fi, I do Wi-Fi, this is where I'm from, right? My background is, early on I worked in education. I was one of the first schools to put Wi-Fi, across a whole school. I've been working with Wi-Fi for kind of 20 plus years. I kind of moved into Wi-Fi because I couldn't find anyone that knew how Wi-Fi worked. So it was like this amazing thing that we were kind of doing with like PCIe, PCMI, the cards that slide into the, man, my brain. Yeah, it was amazing for me. Like I was like, this is incredible. I can access the internet like cable free. This is insane. And obviously Apple did the whole AirPort thing with the hoop and the loving it, and it just blew me away that you could do all this without a cable. And I was just in from day one, right? And so because Wi-Fi wasn't that big when it kind of first came out, I had to kind of do other things to kind of keep the bills and the lights on and all that kind of stuff. So did a lot of like IT support, network, actual physical cable networks, all that kind of stuff. But my passion was always Wi-Fi, right? And so once Wi-Fi got big enough that I could actually make enough money to do just Wi-Fi, that was what I did. So yeah, I've done Wi-Fi for some big spaces, some small spaces, and everything in between. Whether it's like open pit mines, warehousing, stadiums, things like that, right? So I would like to think if you've got an environment, I've probably done it in that type of space, right? So hopefully I can help, right? And that's what I want to be for this community, is a support and a help for people that aren't people that are in Wi-Fi all the time, right? So what is Wi-Fi design and why is it needed, right? First of all, I'm going to show you some free tools that you can use to do Wi-Fi design, right? You might need to use their hardware in the instance of Unify, if you actually want to be able to kind of correlate these things together, right? So the first thing, and this is how I started doing Wi-Fi, get a floor plan, get a beer pong cup, because that's what they are now, right? Draw a circle, and that's, roughly what an AP might give out. No, don't do that, right? But you'd be surprised how that, or I've kind of talked about the finger guns thing, like, oh, let's put one there, let's put one there, let's put one there. That's kind of how people tend to work, right? And I get it, I get why this is why people do it, because in your house, which is where most people experience Wi-Fi, that's how it works, right? The AP gets put in by BT or Virgin or whatever in that place, and then it's like, right, where can I put my mesh nodes so that it hears well enough and then repeats it well enough, right? And it's just a bit of kind of trial and error. So I get why some people think like it's okay in an enterprise environment to just kind of go, there feels about right to put an AP, yeah? I get it. You can use something like the Unified Design Center, and they've got like an updated version, which once you see our software, you might see where Unify have got the inspiration for their new software. Cheers, team. We work with these guys really closely, and when they announced it, we were like, cool, nice, cheers for that. That's useful. Again, the only thing I would say with like the Unified Design Center, it doesn't take into consideration channels, it doesn't even take into consideration power levels of the APs, right? And as you can see, there is no AP on Earth that gives you this perfect circle. No AP on Earth gives you this perfect circle, right? Every antenna, every AP has like a wobbly kind of bit around it, right, which I can show you. So that's your kind of option for the free stuff. Now we're going to go into the cheap tier, right? So I want to be really open and transparent with you about the different types of design tools that are there, okay? So this is the cheap tier, and I know that we're kind of getting on the expensive side with the 2000, but I wanted to kind of give you, these are the cheap options, right? So we've got something like this, which is NetSpot. Who's used NetSpot before? I used NetSpot for years, right? Used it for years. Okay, so this is kind of design, this is kind of survey, right? So in this instance, what you're doing is you're walking around with your laptop and you're kind of going, how loud can I hear the Wi-Fi in this space, right? And that gives you an understanding of how the RF, what I would call, propagates. So what we mean by that is just how the radio waves are kind of seen as they go through the building, right? Then you can move to something like acrylic, which is slightly more expensive. Again, this is like an outdoor one, but again, this is walking around and kind of hearing how loud you're hearing the Wi-Fi and then kind of plotting it down, right? Then we've got this one. I'm trying to remember what this one is. Oh, Tamograph, it says at the top. Tamograph site survey. There seems to be like a recurring theme with these, right? They just look terrible. Welcome to 1997 vibes. Okay, so those are your kind of cheap options, right? Then we get to the enterprise tools. This is where the big boys play, right? So you can go now to enterprise tools, and almost everywhere that you've been that uses Wi-Fi has used one of these tools, right? So here we're looking at Air Magnet. This was like the only game in town for a long, long time, right? And again, this is, you're walking, you're kind of hearing how the Wi-Fi is working, plotting it out on a graph, so that you get an understanding of, okay, if I place an AP here, where this is, how far is that signal going, right? Next one we've got is IB-Wave. So IB-Wave, again, is very enterprise, right? This is the top end. What's nice about IB-Wave is that you can split out your antennas from your radios, from your APs. You can also do like private cellular. This will take into account 3D, all that kind of stuff. This is really, really, really high end. Again, welcome to 1997. And then there's Ekahau, right? Ekahau is probably now the forerunner in Wi-Fi design. And again, what you're doing here is you can go around, you can do a survey, but you can also simulate what that survey will work, right? So what you do is you walk around, you collect all the data, and then you can go in and draw onto your floor plan, you can draw the walls, right? And then you can give that wall an attenuation value, right? So this wall sucks in, absorbs Wi-Fi 3 dB, for instance, right? So half the signal gets cut off from this wall here. And then you go around and you manually draw every single wall. Okay, good. Or you could use another tool, right? Which just happens to be the one that I work for. We have a free tier, right? So go and play with it, use it, you do your house. You can use up to 3 APs on the free tier. See how it works. And then we have an enterprise tier which starts at $590 and goes up, right? So we actually fit within the kind of cheap option that I gave you earlier, right? And this is what we do. So a bit different from kind of everyone else, right? And I think what I want to kind of show you today is the difference now between how we used to design Wi-Fi then, which was a very kind of manual process, very kind of time intensive, if not kind of intelligence, brain, intellectually intensive process, right? So let me show you, first of all, kind of what our software is, right? So first of all, I'm using the test server, and they've done an update since I loaded this up 2 minutes ago. Brilliant. Please watch this now break completely as I try to do my demo. So the big kind of step change that hopefully we've made, right? We wanted to bring down this Wi-Fi design thing to anyone to be able to use, right? And the first thing that helps with that is we have a new bit of hardware. So this is how you collect the Wi-Fi data, right? It's completely cableless, uses BLE. So this is it connected to my Mac now. This is the iPad app running on my Mac. So there's no cable between the two. You kind of don't have to worry about walking around. You can stick that in your back pocket. No one will even know that you're kind of doing it other than your bulky back pocket. Chuck it in a bag or something like that, right? What this is doing is this is scanning through all the channels, collecting all of that Wi-Fi data as you walk around. Why is that important? As you saw earlier with those other ones, right? We need to have like a baseline of how does the actual Wi-Fi propagate in that space? Because if we just guess using kind of random numbers, how accurate can we be, right? So what I want to kind of show you today, and the reason why I think this is important for non-Wi-Fi people, is that you can take, right? So this is our office in Helsinki. I'm just going to delete everything out there, my design. So this is if I'm starting from scratch, right? Got no walls drawn, I've got no attenuation values in there, no nothing, I'm starting from scratch, right? But because I've done a survey using this, right? I've walked around all the spaces I can get to. It's not even that good a survey, I'll be honest, right? I've not done a great job here with this survey. I've just walked around the office as best I can, around the furniture, right? And the way that works is you just have that connected to your phone, you load up the floor plan on your phone, you say, I'm stood here, I'm stood here, I'm stood here, yeah, as you walk around. Right, so we've got our survey. What we now do in this age of AI that we're living in, right, is we take all the millions of data points that we've got here, right? So if I just show you some of these billions of data points. Right, so because we're not just collecting the Wi-Fi that's in your office, right? We're collecting all your neighbour's Wi-Fi, your above you, below you, to the side of you, all this kind of stuff. So if I hover over this here, you can see on the left here, these are all the different APs that we heard, all the signal levels that we heard in all of these environments, right? We've got a shit ton of data, right? We've collected an absolute boatload of the stuff, right? So now, when you go into your simulation, I can take an AP, I like Cisco, but I prefer Juniper. I can place an AP in here, and without even drawing any walls, I can show you how that Wi-Fi is going to work. Right? I've not drawn any walls in. I haven't told it what the attenuation value of that wall is, right? Hopefully now, this used to take me freaking days to do, right? I would go and walk around, I'd get my survey, I'd come back to my empty floor plan, and I would look at, okay, if I'm stood, if I go back to my survey thing, if I'm stood here, and my signal was, I'm going to have to edit this so I can actually see what was going on. Right, if I'm stood here, and I'm connected to this AP, I need to be far enough away, right? So if I'm stood there, I'm neg 68. If I go this side of the wall, I'm neg 65. That's a 3 dB wall. And then I draw a 3 dB wall in, right? And then I go to this one, and I go, right, okay, now this wall, if I'm stood here, it was neg 71. I go that side, okay, that's a 3 dB wall, and I draw a 3 dB wall in. That is literally what I used to have to do, right? Now, I can just drag it around and see how it works, which is freaking awesome, right? So we've taken away a lot of the kind of understanding of like how to draw these things out, right? Now, can I go in and add in a bunch of stuff to make it look pretty for a customer or for a CEO to look at or something like that? Absolutely, you can, and you can make it look pretty with your desks in and all that kind of stuff, right? Absolutely. We're not using, even though we've got walls in there now, right? We are not using the walls and the values of those walls at all. We're just using the actual data that we collected on site to give you a real world, right? Why does this matter? Because if I'm designing in, say, a warehouse, right, or distribution center, or something like that, right, that doesn't have, that has a lot of like shiny floors or metal, cabinets and shelves and things like that, right, that are reflecting signal all over the place. There is virtually no way for us to simulate those reflections with just drawing walls and shelves and things like that, right? But because we're using the real world survey data of how we actually saw the RF, now all of that is taken into consideration. So not only is it quicker and easier to use, it's actually much better in terms of the actual design output that you'll get in the end as well. Right, so I promised you that we were going to actually do a design in 10 minutes, right? So I am staying at a hotel down the road. I took a photo of the floor plan on the back of the door, right? And I'm going to send it to my... I've not done it. Why didn't I test this before? I'm going to send it to my... In fact, I'm going to take a screenshot of this, right? So it's going to be even worse. I'm going to take a screenshot of this and send it to my MacBook Pro. It says it's waiting. Come on. It's because the Wi-Fi's terrible here, isn't it? So that wireless directly isn't working. Here we go. Come on. Come on. It's the slowest airdrop in the history of man. Come on. You can do it. We believe in you. Come on. Let's go. It's like a tiny file as well.
Is it better here than the Hilton?
They are both terrible in different ways. Right, okay. Has that gone into my... Yeah, there we go. Right, downloads. Okay, right, let's set up. Right, let's start the timer. I'm not going to actually start a timer. All right, here we go. We're going to do it in... We're not going to do it in the US because that's too easy. They've got too much. They've got too much spectrum available. Okay, right. I'm going to come into... I need to come out of full screen, don't I, so I can actually get to my... Here we go. Right. This is the floor plan that I've put in from my... that I took a photo of. Let me just duplicate this. We're going to make a 4-story building, right? Rather than just a 1-story, because that'd be too easy. Okay, right, I'm going to come into here. I'm going to go to my align floors. I'm going to tell it to put everything into a building for me. Okay. And then actually while it's doing that, I can start doing some designs on this floor. Okay, so again, what we're trying to do with the AI stuff is automate a lot of the stuff that just took freaking ages for you, right? So I can come in now, I can see this as a floor plan. It's built all the walls for me, right? I don't have to bother walking around clicking all the stuff. It's now actually built the whole building for me, right? So now I can just come in and say, okay, show me the whole building. And there we go. Now it's a dystopian place because the floor plan didn't have any windows on it, all right? So, yeah, welcome to the hotel from hell. But you can see, right? That would have taken me hours and hours and hours in any of those other software that we were using before, right? Because I would have had to manually go through, click every single wall, draw the scope zone around it, cut out the building. In fact, in most of those, you can't even make a 3D building, right? I think it's IBWave and shock surprise, Ekahau announced it like yesterday, that they can do what we've been doing for 3 years. So I've got this, right? So now I can come in here, I can look at my scope zone, right? So where do I actually want Wi-Fi? And it's pretty good at kind of figuring out, okay, this is the building, this is where we want Wi-Fi, right? Then I can have a look at the building edge. Yeah, okay, that makes sense. And then I'll come into the walls. Now in here, I can change what the walls are, right? I can go through and it will look at the different types of lines in a floor plan, and it will assign different materials based on the width of the lines, right? So I can come in and I can change this, right? Say it wasn't concrete, it was brick. I can just come in here, say brick, all that kind of stuff, right? I'm not going to bother with that for now. So I go through here. I can then kind of choose out my scope zones, right? So if I say, well, I'm not bothered about there being stuff in the hallway there or the stairway here, I can kind of take these things out of scope, right? And then I can say, right, okay, you know, I just need a quick kind of bill of materials, right? Let's choose a different one. Let's choose a Ruber. Let's go for the 735. It's so sad that I know these numbers by heart. Okay. I can choose the different modes that they're running in, right? And then yeah, I can just say go and build out a design for me. That is better than. I don't want to be harsh to Wi-Fi people. Half the Wi-Fi people I know, right? That's done a really good job. And I can even do things that only IBWave can do in terms of things like cabinets, right? So I can come in, I can put a cabinet in, I can come and put some cable trays in here. I'm being super lazy here, I'm just doing it like this. Let's just say our cable trays do that, right? And you can see how now all of the APs route through the cable trays back into the switch. I can click on the switch and I can see exactly kind of how much cable length I need, power levels, all that kind of stuff is all in there, right? And I can just go through and I can do this for the whole building, right? So if I go through here, I can say, okay, that's 4.3, that's 4.2, 4.1, ground floor, for instance, right? And bearing in mind, that has built a whole 3D, I think I kind of glazed over that, I see this all the time, right? A whole 3D building, that's pretty impressive from just flat JPEG files, right? I don't give our AI team like enough credit. It's like, yeah, that's normal to me now. Yeah, so I can walk through. Right, say for instance, we don't have a closet on this room, right? But we do have a cable riser. I can't even remember where I put the thing now. I think it was here. Right, so I can put the cable riser through there. I can come and do the cable trays again. Now you can see, because we've got the 3D building, it also knows like how much signal is coming through from the floor above, right? So now it'll even take that into account if I now say to it, okay, go and do me another plan again, right? It's done a worse job this time. Classic. Okay, let's just add another couple of APs in. Okay, happy with that. I can go down to the floor below. Again, I can accept kind of all these things. If I don't accept it, it will just use what I've already used, right? So you can see how, even though I haven't told it there are walls on here, it's kind of just assuming there are walls here, right, where it's seen them. So again, I can do the same thing. I can put my cable trays in. I can run all the way through here, do that, and then we'll chuck these autoplan APs in, right? So why is this important, right? Because now I can go and show someone before we've even built out this building, right? This could be a brand new building that no one's been to before. It's not even been built yet, right? Now I can show someone exactly how the device will roam from AP to AP as they walk around this building. Let me just keep ones below, right? So I can show someone, hey, if we've got an iPhone 17 Pro and they're walking around this space, this is how their device is going to work in this environment, okay? Now, bearing in mind, this is one where I haven't done a survey first, right? So now we are using the guesstimated wall values, right? But if I've done this on one where I've got that survey data, it's like 99% accurate. We've never had the opportunity to have that in Wi-Fi before, right? So because we'd be using the actual kind of, let me show you back on the NIST lab that we've got back in the office. This is using, because we've got the survey data, this is using the real world understanding of how these APs are, right? So I can see this is how that's going to work in that space. I can see when that device is going to roam from there to there. I can see here, I've got two different types of things, right? There's a blue line back here showing me the primary connection, and then there's a grey line there. What's that grey line for? That's showing me the other AP that I could be using if that blue-lined AP was too busy. Right, so I can show that I've built redundancy into my design, that I know that if the space gets really busy, I'm going to have a backup connection that I can use. Right? And I can walk my way through, and I can check, right, CEO's office, if I walk to the boardroom, perfect, they're going to have a good time. Right? I have just absolved myself of having an awful effort. I can come in here and I can pick a MacBook. And you can see how it changes the blue space, right? So the blue space is how long you'd stay stuck to that AP, right? So if I change it from a MacBook to an iPhone, see how they've got different spaces. That's because they've got different trigger thresholds. They've got different. We've worked with Apple to build all of that in. Their roaming algorithms are all built into what we've got here, right? The last thing I want to show you really quickly, that's all well and good. You've done your design, you've deployed it, you've kind of validated that it all works, all that kind of stuff. What about when it's up and running and on site? If you've got a cloud vendor, like a Meraki or a Juniper or something like that, we can actually use their APIs to pull the data through into here. All right, so this is our office in Helsinki right now. Okay, that is the coverage of that AP right now. How do I know that? Because I know how the RF propagates in the space. I know that it's a Juniper AP45, so I know the antenna pattern that that's got. I know that the power level is at 10 dBm on the 5 GHz radio, and I know how far the RF propagates in that space. This now is a remote survey without me having to be in Helsinki, and I can see exactly how the Wi-Fi is working. Right, so if I come into here and I want to look at how utilized is the Wi-Fi, I can see it. Right? And from the vendor dashboard that you've got, you'll see a number. It's 15% utilized. Great. Where? Just under the AP? Like how far does that go? I've now got blast radius of the users, the areas that that's affecting, because we've got all that data of how the RF works, how loud it is, all that kind of stuff. And we can even go and see the CEO, or Ken Brockman in this instance. We can go and click on their device, see what their actual user experience is. So this is running an agent, so it's testing the user experience all the time. And I can see all of the data of how this client is working. If this client was to roam, I would see it roam in real time. So now I've got something I can actually action and actually work with. Cool. Okay, we've got like 4 minutes for questions and stuff. Like no one jumped in and asked a question, so I'm upset with you guys. Any questions about any of this stuff? Like something you're going through at the moment, a question about design, like yeah, go for it.
It's specific to our it's specific to our environment. But we've got an office, and we seem to be getting a random high ping every 10 seconds.
Okay.
Which is causing issues with Zoom calls.
Yeah.
And we have tried everything that we can think of to try and sort this out.
Yeah.
And we just can't figure out what it is. It's something to do with Wi-Fi. So if you're wired, it's not a problem. But.
Okay, so have you got QoS enabled on wireless, separate from your wired infrastructure?
I believe we do, yeah.
Okay, because there's so QoS on the wire, right? Most people know how QoS works on the wire. QoS on wireless works really differently. So anyone play D&D, different dice and things like that, right? Yeah. So if you normally, right, if you've not got QoS enabled, everyone rolls a D20, right? So 1 to 20, right? You can pick a number, right? It's not 1 to 20, but for this thing, 1 to 20. If you turn on QoS for specifically something like Zoom, right? So it has to work both ways. So the OS has to be turned on the device, and then the OS has to actually move that from the application up, right? So for instance, Microsoft Teams doesn't automatically do that. You have to turn on a flag to make it work with Teams. Zoom, I'm not so sure, but you'd have to research it. But so the way that the QoS works is, if it sees that Zoom is doing it, rather than a D20, it will give them a D4, right? And basically, when you get to 0, that's when you're allowed to transmit. The nice thing about QoS with Wi-Fi is you not only get a D4, but you get to roll it before everyone else. So you should get that thing beforehand. That's what that sounds to me like from when I've seen it before, when you get like a spike of something else. Because normally what that means is you've got a higher retry rate, and with voice data and retry rates, it might be that you've got too many devices doing that D4 at the same time. So, you know, if you've only got 4 slots and you've got 8 people rolling a D4, you're going to have collisions, right? You can only retry something 3 times before it just drops that packet. So it sounds like in that particular area where you are, you've got too many people doing QoS and you don't have enough nav slots to get it through in time. So either you need to put more radios in to give yourselves more nav slots, or you need to turn off QoS, which sounds weird, but actually sometimes that is the way to fix that.
We've got like one more.
Ah, sorry guys.
So suppose we do the survey, we see there's a problem.
Yep.
What's the number one fix we're looking for? Is it put in more access points? Is it change radio settings?
Yes. Okay, so let me show you using this, right? This is the network here live right now. First thing I'll show you is that the status, the experience score, is 91 out of 100. That's actually pretty good, right? Wi-Fi is so resilient. The Wi-Fi here is bad, right? It is bad. But they've got so much back-end bandwidth, it's covering for the fact that their Wi-Fi is bad, right? This is what you're seeing in terms of lag, right? So actually, in terms of like the actual internet experience, it seems like it's okay. Now, none of you are like doing stuff like streaming on your phone, things like that, right? As soon as people started working on this Wi-Fi, it would fall apart, right? Let me show you what the problem is with this Wi-Fi here. Okay, first problem, they have got 80 megahertz wide channels, right? They are giving big lanes for data. You only need 80 megahertz wide, never, right? So the widest I would ever go would be 40 on 5 gigahertz, and that is only if you are doing large file transfers back and forth. Then I would use QoS to make sure that my voice data is going before my background task, large file transfers, right? The best option they could do in an environment like this is go to 20 megahertz wide channels, right? Because that just makes sure that rather than one device being able to talk at a time, 4 can talk at a time, right? So in this instance, config change. They've also got 839 SSIDs on this coming out of the same box, right? People do this when they don't understand how Wi-Fi works, right? They go, well, if it's on a separate network, then it's all separate, right? No. The way I explained this earlier was you've got a single lane. Your corporate devices are Ferraris, right? They're allowed to go 120 mile an hour in this lane, right? And you're saying to all your guests, look, because we want our Ferraris to be able to go fast, everyone else has to drive at 30 mile an hour. What they don't realize is they just put a Fiesta in front of their Ferrari driving 30, and now the Ferrari can only drive 30, yeah? So that's probably what's happening here too, but also just the overhead. Every time you add an SSID, it has to say, this is my name, this is what I'm capable of, this is what you can access, this is what you can do on that network, right? So if you have only 3 networks doing that, that happens pretty quickly and they're off the air. If you've got 837, like they do here, then what you're going to find is all that's happening is your APs are telling your clients, look how great we are, these are what we can do, and there's no time for data to actually be sent. So that's the problem here. It might be a similar thing where you are. But please come and find me, talk to me, ask me. I really want to help this community, so yeah.
Thank you very much.